In this series of videos, we will use Precision Tree to demonstrate the expected value of perfect information. This is part 2 of the series. How can we place a value on more information in a decision problem? This is the model that we concluded video number 1 with. Suppose there's an expert on these developments who can tell us with 100% certainty whether success would be strong, moderate, or weak. How much would we be willing to pay for this perfect information? Let's look at the second influence diagram. Notice this diagram adds an arc from success of the Sweet Virginia project to the number of condos. This change is telling us that we know the answer to the success question before we make our decision. Notice the format of the payoff information is arranged differently now. Notice that the expected value of the project with perfect information is $1,650. Notice also that the minimum is different when we can choose with perfect knowledge of the outcome. Here the minimum is 0, and with uncertain information the minimum is minus 2,000. With the current uncertainty, the expected value is $1,160. It rises to $1,650 with perfect information. The difference is $490, and that is the maximum value of perfect information. Remember, we're estimating the value of perfect information before we have that information. Once we buy it, we will either go 90 condos if success will be strong, or we will go 30 condos if success is moderate or weak. Let's look at the corresponding decision tree. We have 4 decisions at the outset: 90 condos, 60 condos, 30 condos, or purchasing perfect information. The top 3 branches from the decision node lead to chance nodes that show us the expected value of each development size under uncertainty. These are values that are familiar from the first decision tree model. The best expected value is obtained from 90 condominiums and is shown here in cell C6. However, the bottom branch of the decision node uses a Bayesian flip of the order of the information. Notice now the project size follows the success of the project. This is just the opposite of what we see above, where the project size precedes the success of the project. In cell C36, we see the expected value of the information is $1,650. Notice that the model shows the best choice, false, 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 and true. This is the choice that maximizes the payoff. So if we can hire the consultant for less than $490, we can expect to gain by reducing the uncertainty with perfect information. Buying imperfect information, which most information is more complex, and that's the subject of the next video.